The number of cases represents the various options or choices that can occur under specific conditions. Counting the number of cases for selecting items from a short list is relatively easy. However, there are times when there are so many options available that it becomes impractical to count all possible outcomes. The basic method for calculating the number of cases is the fundamental counting principle. If event A has a possibilities of A, and event B has B ways, then the number of cases where event A and event B occur consecutively is calculated as A times B. For example, if there are 4 shirts and 3 pairs of pants, the number of cases for outfits would be 4 times 3 equals 12, meaning there are 12 possible outcomes. Let's consider the paths connecting 3 points. If there are 4 possible paths between the first 2 points and 5 possible paths between the remaining 2 points, then there are 20 possible pathways, calculated as 4 times 5 equals 20. Permutation. It refers to arranging given items in a specific order. If the order of the given elements differs, the arrangements are considered different. For example, with letter cards A, B, C used once each, what words can be formed? The first selection can be any of A, B, or C. The second selection can be any of the remaining 2. The third selection is the last remaining card. Words formed using the 3 letter cards once each are ABC, ACB, BAC, BCA, CAB, CBA, totaling 6 ways. This representation of possible outcomes resembling branches of a tree is called a tree diagram. The number of choices for the first selection is 3. For the second selection, it's 2. And for the third selection, it's 1. Multiplying these together gives 6. Using the fundamental counting principle. In this case, you can also use factorial to calculate. N factorial represents the product of all natural numbers from n down to 1. Here, with 3 choices for the cards, it's 3 factorial, yielding the same result of 6 possible ways. When selecting R items from N items and arranging them in order, you can use the permutation formula. Let's consider the following example. From a math club consisting of 10 members, how many ways can we choose 2 members to be the president and vice president? Using the fundamental counting principle, we find that there are 10 choices for the president and 9 choices for the vice president, resulting in 90 possible scenarios. Alternatively, we can use the permutation formula, because the order of selection for president and vice president matters. Here, N is 10, total number of members, and R is 2, number of members to be chosen. Substituting these values into the formula, the numerator becomes 10 factorial, and the denominator becomes 8 factorial, which can be simplified to 10 times 9. It is 90. Therefore, we confirm that there are 90 total possible outcomes. When selecting a subset of items without regard to order, it's called combination. In other words, combinations treat different orderings as the same set. The combination formula differs from the permutation formula in that an additional R factorial term is added to the denominator. Let's revisit the previous example with a slight modification. In a math club of 10 members, how many ways can we choose 2 members to be co-representatives? For this scenario, we can use the combination formula because there's no distinction in the order of selection for co-representatives. Here, N is 10, total number of members, and R is 2, number of members to be chosen. Substituting these values into the formula, the numerator becomes 10 factorial, and the denominator becomes 8 factorial 2 factorial, which simplifies to 90 over 2. It is 45. Therefore, we conclude that the total number of combinations is 45. See you next time!